For decades, scientists could only theorize about what happens when you fall into a black hole. But in 2025, revolutionary simulations combining Einstein's gravity with realistic behavior of light and matter have finally revealed the complete experience, from the moment you cross the point of no return to your ultimate fate at the singularity. What would you actually see, feel, and experience during humanity's most extreme journey? As you begin your descent toward the event horizon, time itself becomes your first adversary. The closer you get to the black hole, the more dramatically time slows for you relative to distant observers. If you could somehow hover just outside the event horizon for what feels like a single year, 141 years would pass on Earth. But you're not hovering, you're falling freely, and the universe around you begins to transform in ways that defy everyday experience. Looking back toward the stars you left behind, you'd witness something extraordinary. The entire future history of the universe accelerates behind you. Distant galaxies would age millennia in moments. To outside observers, you'd appear to slow down infinitely, getting dimmer and redder until you vanish, time dilation in full force. This brings us to the most crucial threshold in your journey, the point of no return. Then comes the event horizon, where space-time distortion becomes so extreme that even light can no longer escape. You've crossed into a realm where the rules of reality fundamentally change. At the precise moment you cross the event horizon, your clock continues to run just fine, and time flows normally. You would fall through the horizon in a finite time without noticing any barrier. No dramatic sensation, no wall to break through, no cosmic alarm bells. The crossing itself feels unremarkable, a geometric threshold rather than a physical one. But while you experience nothing special, outside observers witness something radically different. The light you emit as you fall takes longer and longer to reach distant observers as you approach the horizon. At the horizon itself, your outgoing light becomes trapped forever. Your signals stretch into longer wavelengths, your image fading into redder tones until it vanishes entirely. To that observer, you never quite cross the horizon. You hover, frozen in time, fading into darkness. This asymmetry reveals the true nature of what you've crossed. Not a physical barrier, but a geometric point of no return where space-time itself has been warped beyond recognition. So, if you had to choose between experiencing that crossing yourself or watching someone else fall in from a safe distance, which would you pick? To that observer, you would never quite cross the horizon. You would hover, frozen in time, fading into darkness. But your own experience would be utterly different. To you, time flows normally. You would fall through the horizon in a finite time without noticing any barrier. Comment your answer below. Now, as you pass beyond that geometric threshold, the real journey into the unknown begins. Once you're past the event horizon, your experience shifts from the strange effects of time dilation to something far more physical and immediate. As you continue your journey into the black hole's interior, your body becomes the battleground for forces that have no earthly equivalent. The gravitational pull on your feet becomes significantly stronger than the pull on your head, creating what physicists call tidal forces, the same mechanism that moves Earth's oceans, but here amplified to lethal extremes. You would feel your head stretched away from your feet, a sensation that grows more intense with each passing moment. Simultaneously, gravity compresses you from the sides, squeezing you horizontally as the black hole's immense mass pulls everything inward toward its center. The stretching and compression work in tandem, transforming your body's familiar proportions into something unrecognizable. The point at which tidal forces destroy a person depends on the black hole's mass, but regardless of size, the outcome remains inevitable. You undergo unlimited stretching that turns you into a long, thin line of subatomic particles, your molecular bonds no match for the differential forces tearing you apart. Physicists have given this process a deceptively whimsical name: spaghettification. But even as your physical form succumbs to these extreme forces, a deeper question emerges about the very essence of what makes you you, the information encoded in every atom, every quantum state, every memory that once defined your existence. This leads us to one of physics's most profound puzzles. For decades, physicists grappled with what seemed like an impossible contradiction. If information truly disappears into a black hole, it would violate quantum mechanics' most fundamental principle that information must be preserved. Recent breakthroughs suggest this paradox may finally be resolved, with theories proposing that information is ultimately preserved through quantum mechanisms, regions where quantum entanglement between the black hole and its radiation ensures that your information, while scrambled beyond recognition, never truly vanishes from the universe. The information returns in a highly scrambled, chaotic form, though for all practical purposes, the version of you that fell in can never be reconstructed. Finally, we reach the ultimate destination of this cosmic journey. At the very center of the black hole lies the singularity, the final destination where all your remaining matter converges into a point of infinite density. At this singularity, our understanding of physics and time breaks down. But recent research suggests this endpoint might not be the absolute termination scientists once believed. Using quantum mechanics, some theories propose the singularity is replaced by a region of large quantum fluctuations, tiny, temporary changes in the energy of space, where space and time do not end. Instead, space and time might transition into a new phase. Rather than experiencing complete annihilation, you could theoretically emerge into an entirely different realm of existence. Your journey through the black hole, from the initial approach to the final transformation, reveals the universe's most extreme physics, a passage not into nothingness, but potentially into a fundamentally different phase of reality. Subscribe for more space mysteries solved by cutting